Hello, welcome to this video on how to set up a NAT gateway on Hetzner Cloud. My name is Niels and you're on heitbrink.dev. I have the Hetzner Cloud console open and will first create a network. I will name mine NAT example and give it an IP range of 10.21.32.0 divided by 24. I will then create the actual NAT gateway server. Let me walk you through all the settings that I chose. I'm running the server in Falkenstein using Fedora 40. I chose the cheapest instance type as we don't need that many resources and disabled the public IPv6 and chose the private network I just created. I also enabled a firewall to limit traffic to my private network. Finally, I gave the server a name called NAT gateway and clicked create and buy now. Let's wait for the server to come up and add a default route to our Hetzner Cloud network. This is necessary because Hetzner manages the default gateway in any private network, so we will add the routing configuration here. I'm configuring a route to send all packets regardless of destination to the NAT gateway server. You can do that by choosing 0000 divided by 0 as the destination and subnet. Let's move on to creating the client server. Once again, I chose location Falkenstein and Fedora 40 and the cheapest instance type. Please note that I disabled all public accessibility, so both public IPv4 and public IPv6, and only chose the private network as the single interface on this instance. I also gave the server a name called client, and once you're done, click create and buy now. Let's wait for both servers to be up and running and SSH into both servers. I'm using tmux so you can see the NAT gateway on the left and the client on the right. To connect to the NAT gateway using SSH, I'm just using the public IP. However, as the client does not have a public IP, I'm using the NAT gateway as a jump host to connect to the private network. This is indicated by the -j flag in the SSH command. Let's check the network connectivity first using nmcli, as Fedora 40 comes with NetworkManager pre-installed. As you can see, the public interface ETH0 is managed by NetworkManager per default on the NAT gateway. However, the private interfaces on both the NAT gateway and the client are unmanaged. For the purpose of this tutorial, I would like all interfaces to be managed by NetworkManager to make it easier for you to understand and configure everything in the same way. Using nmcli dev and nmcli con, you can check the relevant devices and connections we have configured. As you can see, enp7s0 is unmanaged on both servers. To make it easier to read the following commands, I switched the layout from a vertical split to a horizontal split. The NAT gateway is now on top and the client is on the bottom. Let's first figure out why the private interface is unmanaged by NetworkManager. To check that, I will list all active system services and check for a networking service that may take precedence of managing the private interface before NetworkManager. As you can see, there is this hc-NAT if up at enp7s0 service. And in the description you can see enable Hetzner Cloud private network interfaces enp7s0. Now, this is most likely the service that is managing the private interface and therefore preventing NetworkManager from taking management of this interface. Using system control status, we can see that this service is actually active and running. As I mentioned in the beginning, I would like NetworkManager to take management of all of the interfaces that we have. To achieve that, I will first stop this service on both systems and then remove the hc-utils package. This is a package that comes pre-installed on Hetzner systems, but is also responsible to set up this hc-NAT if up service that we want to disable. After that's done, run system control daemon reload to let system control know about the changed system services. Now if you run nmcli dev and nmcli con, we can see no change. NetworkManager would only take management of the private interface upon a reboot. However, if you reboot now, it is likely that you cannot connect back to your instance using SSH. This is because the default route on enp7s0, so the private interface, may take precedence over the default route on ETH0, which enables public connectivity for your NAT gateway. Thus, you will not be able to connect on this public IP, because per default it will try to route into the private network. To fix that, we will need to manually configure the IPv4 route metric for both ETH0, so the public interface, and enp7s0, so the private interface. Using nmcli dev connect enp7s0, I will manually activate this connection. And if you run nmcli dev and nmcli con again, you should see that all interfaces and connections are green, meaning that they are managed by NetworkManager. Please note that we only need to update the IPv4 route metric property on the NAT gateway, not on the client, as only the NAT gateway has multiple interfaces to choose from. I will change the connection name of ETH0 from cloud-init ETH0 to just ETH0 to make it a bit more consistent and easier to understand what I'm talking about. That way the device name and connection name is the same. Okay, so checking with nmcli dev and nmcli con one more time, you should see all devices active and the device name to be equal to the connection name. Let's check our IP and routing configuration on the NAT gateway one more time. As you can see, NetworkManager shows all of the correct configuration regarding IP assignments and routing. You can also see the conflicting root 4 entries here. Both ETH0 and ENP7S0 have a root 4 default entry. To make sure that the default root on the public interface is preferred on the NAT gateway, we will now set the IPv4 root metric property. To do that, we will run nmcli-con modify, and first for ETH0 we will set IPv4 root metric to 100, and then for ENP7S0 we will set it to 101. The metric property on a root indicates the preference, while a lower value will lead to higher preference of this root being chosen. By setting this to 100 and 101 respectively, we have ensured that the default root set on ETH0 will be preferred to ENP7S0. Checking this configuration using nmcli, you can now see ETH0 has the root metric set as 100 and ENP7S0 has it set as 101 as expected. Let's now set up the actual NAT gateway component. For that we will install iptables and configure a startup script using the NetworkManager dispatcher service to run every time the interface is enabled. What does this script do? This ensures that the configuration is persistent across restarts. If we were to run any of those two commands manually right now, we would achieve the same effect. However, once we reboot, the changes would be reset and we'd have to run the commands again. The first line will enable IP forwarding on the machine. This is necessary so this server can act as a router within the network and can accept packages from any source within the network and forward it to the internet. It is also necessary for this server to accept packages from the internet destined for another server. Using iptables, we will append a post-routing rule to the NAT table, defining that we want to masquerade any packet coming from the source 10.21.32.0 divided by 24, so within our cloud network, and send it out on ETH0. So the way that would work is the client would send a packet to the NAT gateway server as it's the default gateway. The NAT gateway server receives the packet and rewrites the source IP to its own IP and forwards the packet on its own public interface. Let's do a quick ping test to see which components we can reach within the network. For that, I will run the same ping on both the NAT gateway server and the client. Let's first ping the default gateway, and on both sides we can get a response back. Let's then ping both of the servers respectively. And again, we have verified that the connectivity within the network is working as expected. Now let's check if internet connectivity is working. And here we can see that no, on the client we don't have internet connectivity yet. Of course, on the NAT gateway we do have internet connectivity as expected because the NAT gateway has its own public IP. Just for fun, let's also ping google.com, and as expected, on the NAT gateway we do get a response, but on the client we don't get a response as we don't have any name resolution configured. We will now reboot the NAT gateway for the changes to take effect. As mentioned before, the network dispatcher script will only run if the interface is enabled, and we haven't disabled and enabled the interface yet, so let's do that using a reboot. Because I'm connected to the client through the NAT gateway as a jump host, both SSH connections drop now. Let me reconnect, and let's run nmcli-dev and nmcli-con to check that all devices and connections are still managed. And as you can see, they are. Meaning that there are no conflicting services taking management of any of the interfaces anymore. Let's also run nmcli to see the configuration, and as we can see, everything's configured as expected. We have ETH0 with the public IP assignment and routing configuration, and ENP7S0 on both servers with the private IP configuration and private IP routes. You can also see specifically on the NAT gateway that the metric is set correctly, meaning that routes on ETH0 take precedence over ENP7S0. Let's run the same ping test one more time. No shock here, we can still ping our default gateway, and both servers can ping each other, respectively. However, if we try to ping 1111, we can see that internet connectivity is now also working on the client as we get a response back. And let's try to ping google.com one more time. And as expected, we still don't have a name server configured on the client, so that will fail. So let's do that now. Let's configure a name server. Using nmcli-con, you can see our connection name is ENP7S0, same as the device. And using nmcli-con show, let's check the IPv4 configuration, specifically IPv4.DNS and IPv4.routes. Now, because the default route is configured using DHCP, it is not strictly necessary to add it manually. However, just as a maybe best practice or to be sure that it keeps working in the future, let's add this route manually. I do that using nmcli-con modify and then appending the IPv4 route 0000 divided by 0 using the next hop 10.21.32.1. Now let's set the DNS servers. Again, you can do that using nmcli-con modify, but now setting the IPv4.DNS property you can configure fallback servers by separating them with commas. And I'm using the Cloudflare DNS servers, so here I'm setting 1111 and 1001. Using nmcli-conshow one more time, you should now see those properties set under the IPv4 section. Let's restart the NetworkManager service for the changes to take effect. I suggest you don't use nmcli-con down or dev down to restart the connection or interface respectively, as you will immediately lose SSH access when doing that. Using system control restart, it will automatically bring up all the interfaces again, ensuring that you stay connected using SSH. So now if you ping google.com on the client, you can see we also get a response back. Let's reboot both systems to ensure that we have achieved persistent configuration. And upon the reboot, I will reconnect, run nmcli to verify that everything's still configured as expected. And as you can see, it is. Especially on the client, you can now also see the default route and the DNS configuration. And running the same ping test as before, we can unsurprisingly see that we can still ping any location within the network, so the default gateway and both of the servers. We test internet connectivity by pinging 1111, which is also working. And then we test DNS resolution by pinging google.com, which is finally also working. So there you go, that's all the setup done. Finally, I want to show you an easier and more automatable way to set up the NAT gateway and client. To do that, I will delete the servers that we just created and create two new servers. First, the NAT gateway, and I'm choosing the same settings as before. So location Falkenstein, Fedora 40, cheapest instance type, no public IPv6, but I will attach the server to the private network, select my firewall. But now, one notable difference is the cloud config script, where we will essentially be running all of the commands that we ran manually before, but automated when the instance is set up. So in the first block, you can see that we are removing the hc-utils package and therefore the hc-NAT if up service. We will manually connect ENP7 as 0 to set the route metrics correctly. Then we update the connection name and the route metrics for both ETH0 and ENP7 as 0. And then set up iptables and the NetworkManager dispatcher script as we did manually before to persist the configuration, make that script executable, and reboot. Let's create the server, and while we're waiting, let's create the client server. Again, same settings as before. Location Falkenstein, Fedora 40, cheapest instance type, no public IPs, but only the private network attachment, and finally the cloud-init script for the client. Here we will also remove the hc-utils package, manually connect ENP7 as 0, and add the default route using the nexthop 1021.32.1. and setting the DNS servers to Cloudflare DNS in my case. Click on Create and Buy Now. Let's connect to both servers using SSH again. Using nmcli, you should be able to see all of the configuration set correctly, meaning on the NAT gateway server, you should be able to see the correct route metric being set for both the public interface and the private interface. And then on the client server, you should be able to see, again, the default route being set, but also DNS configuration being set correctly. Again, same ping test as before. We will ping the default gateway, which is working. We will ping the NAT gateway and client servers respectively, which is also working as expected. Now we will ping an external IP, which is also working on both systems. And finally, we will check DNS resolution by pinging google.com, which is also working as expected. Congratulations, you've set up your own NAT gateway on Hetzner Cloud. See you next time.